1. Title: New Trigonometry, DJ Trigonometry. Author: DJ Badwan. Age: 17. Email address: d.j.badwan@gmail.com. https://orchid.org/0009-0005-7836-4204. Trigonometry. Author: DJ Badwan. Age: 17. Email address: d.j.badwan@gmail.com. https://orchid.org/0009-0005-7836-4204. Collage: Shahid Bhagat Singh Shasaki Snatak Mahavidyalay Ashta Madhya Pradesh. Location: India, Madhya Pradesh. Ashta Village, Kamketa Jatra. 2. Abstract T. Abstract. This research paper introduces DJ Trigonometry, a novel mathematical framework designed to simplify and modernize the study of angular and linear relationships in geometric figures. Unlike classical trigonometry, which relies primarily on circular geometry and functions such as sine and cosine, this new system establishes a polygon-based proportional framework applicable to closed figures like triangles, squares, and rectangles. Central to this methodology are the d constant and the dj measure, which define new angular units. The dj system establishes a polygon-based proportional framework applicable to closed figures like triangles, squares, and rectangles. Central to this methodology are the d constant and the dj measure, which define new angular units, the dj angle and dj degree, rooted in square geometry rather than circular arcs. To facilitate practical application, the paper introduces the DJ Protractor, a specialized geometric instrument designed to accurately measure these unique angles and align shapes according to the DJ system. The study further presents the DJ Badwan Theorem, which asserts that in a right-angled triangle, the length of the opposite side can be determined by directly multiplying the adjacent side by the DJ measure, thereby replacing traditional trigonometric ratios. Additionally, the DJ theorem generalizes this approach to any triangle, acute, obtuse, or scalene by utilizing a perpendicular to divide the shape into resolvable right. Specialized geometric instrument designed to accurately measure these unique angles and align shapes according to the DJ system. The study further presents the DJ Badwan Theorem, which asserts that in a right-angled triangle, the length of the opposite side can be determined by directly multiplying the adjacent side by the DJ measure, thereby replacing traditional trigonometric ratios. Additionally, the DJ theorem generalizes this approach to any triangle, acute, obtuse, or scalene by utilizing a perpendicular to divide the shape into resolvable right-angled components. By bridging the gap between algebraic proportionality and geometric analysis, DJ Trigonometry offers a universally valid, intuitive, and computationally efficient alternative for mathematical education and applied geometry. 3. Keywords. 3. Keywords. New trigonometry, DJ trigonometry, constant E, DJ measure, DJ angle, DJ degree, simplified mathematics, DJ Protractor, DJ Badwan Theorem. DJ Theorem, DJ acute angle. 4. Introduction. In-text citation to fix the error. Traditional trigonometry describes the relationship between the sides and angles of a right-angled triangle using circular functions and classical angle measurements. 1. In contrast, the present work introduces DJ trigonometry, which extends proportional relationships to polygon-based closed figures. The author's short name, DJ, is formed from the first letter, D, and the last letter, J, of the name. DJ, and it is under this abbreviated name that he has introduced the new system of trigonometry called DJ Trigonometry. About 15 to 20 major mathematicians played an important role in the development of trigonometry. Although hundreds of scholars contributed over time, the following are considered the most significant. Trigonometry is a very ancient and important branch of mathematics. Many great mathematicians contributed to its development, such as Hipparchus, Ptolemy, Aryabhata, Bhaskaracharya, and Newton, among others. Aryabhata, Bhaskaracharya, and Newton, among others. All of them played a key role in understanding the relationships between angles and sides, and in applying trigonometry to astronomical and geometric calculations. However, DJ trigonometry is a new and modern concept, created by only one person, DJ Badwan. It presents the principles of traditional trigonometry from a new perspective, introducing the DJ measure and unique theorems like the DJ Theorem and DJ Badwan Theorem to explain mathematical relationships in a fresh and innovative way. Traditional trigonometry, with its reliance on degree measures, protractors, and radians, has long been associated with the study of circular, cylindrical, conical, and spherical forms. It primarily serves as a mathematical tool for analyzing shapes and motions that exhibit rotational or curved symmetry. However, DJ Trigonometry, a new mathematical framework named after the author's initials, marks a significant departure from this classical approach. Unlike conventional trigonometry, DJ Trigonometry is specifically developed to address closed geometric figures composed of three or more straight sides, such as triangles, squares, rectangles, cubes, and cuboids. By shifting the focus from circular geometry to polygonal and polyhedral structures, it introduces a novel way to interpret angular and linear relationships in non-circular systems. The principal aim of this innovative system is to simplify the complexity of traditional trigonometry, which is often perceived as abstract and challenging for learners. DJ Trigonometry reimagines the foundational concepts of angle and side measurement through more intuitive and accessible formulations. As a result, it stands as a potentially transformative advancement, offering a simpler yet equally powerful means of solving geometric problems. In particular, it enables the determination of side lengths and angle relationships for any type of triangle, whether acute, obtuse, or scalene, thereby broadening the scope and usability of trigonometric analysis. 5. Methodology. DJ Trigonometry. DJ Protractor. This instrument is specially designed to help in finding and measuring DJ angles accurately. Unlike the traditional protractor used in standard trigonometry, the DJ Protractor works according to the DJ trigonometric system, which measures angles based on a new degree scale developed for greater precision and simplified geometric understanding. It helps students and researchers visualize and determine the DJ angles easily by aligning geometric shapes, such as squares or special DJ circles, according to this system. This tool plays an important role in modernizing traditional angle measurement methods and serves as a bridge between classical trigonometry and the newly developed DJ methodology. DJ angle. The DJ angle is a unique concept introduced in the DJ trigonometric system, representing a modern way to measure and understand angular relationships. This special angle is derived directly using the DJ Protractor, which serves as the special angle is derived directly using the DJ Protractor, which serves as the primary tool for its accurate determination. The relationship between DJ measure, DJ angle, and DJ Protractor forms the mathematical foundation of this system, expressed as DJ measure equals DJ angle equals DJ Protractor, DJ degree. Angles in a circle, ordinary degrees degree. A full turn around a circle equals 360 degrees. An angle of 90 degrees means the ray has rotated of a full circle. Degrees and radians measure rotational amount directly. Measure rotational amount directly. DJ angle, in a square, ordinary DJ degrees degree. Measuring angles in the square using DJ degrees, that means I have introduced a new unit for measuring angles on the square. The simplest approach, define a full rotation to equal 360 DJ degrees. This relationship shows that all three elements are interconnected and work together to define the geometry of shapes under the DJ system. Using these relationships, one can calculate important geometric properties, such as the perimeter of a square, in terms of the DJ angle. This innovative approach not only simplifies trigonometric calculations but also introduces a new perspective in mathematical measurement, blending geometry, algebra, and modern trigonometric thinking into one unified framework, the D constant. In DJ trigonometry, the concept of the D constant serves as a fundamental element in redefining the geometric relationships between sides and perimeters of closed figures. To explain this concept, let us begin with the example of a square. The perimeter of a square is expressed by the conventional mathematical formula P equals 4a, where represents the length of one side of the square. However, in DJ trigonometry, this relationship is further analyzed through its connection with the radius r of an imaginary circle inscribed within or circumscribed around the square. Assuming that each side of the square can be represented as, the perimeter becomes P equals 4 2r. From this expression, the numerical factor 4 appears as a repeating constant that maintains the proportional relationship between the perimeter and the radius. This constant factor, 4, is redefined in DJ trigonometry as the d constant. Thus, the expression for the perimeter of the square can be written as p equals 2 dr. Here, the d constant represents a universal multiplier that connects linear measurements, such as radius, with the perimeter of polygonal shapes. It symbolizes the direct relationship between side lengths and overall geometric boundaries, acting as a bridge between traditional linear geometry and DJ trigonometric analysis. Conceptually, the d constant may be viewed as a foundational unit of proportionality, similar in philosophical importance to constants like pi in circular geometry. Just as pi relates a circle S circumference to its diameter, the d constant relates the perimeters of polygonal figures, like squares and triangles, to their respective radii or side-based parameters. This simple yet profound redefinition forms the backbone of DJ trigonometry, S approach to simplifying geometric relationships while maintaining logical mathematical consistency. DJ measure. This constant is known as the DJ measure. Therefore, the relationship can be written as perimeter of the square equals DJ measure R. Here, the DJ measure is equivalent to the DJ angle or DJ protractor, signifying a fixed proportional factor between the perimeter and the radius. In other words, the DJ measure serves as a unique mathematical constant that connects linear and angular properties under this geometric model. DJ measure serves as a unique mathematical constant that connects linear and angular properties under this geometric model. By applying this concept, the perimeter of a square can also be represented as perimeter of a square equals 8r equals 4a. This demonstrates that the DJ measure plays a crucial role in defining the proportional relationship between the side of the square, its radius, and its overall perimeter, establishing a unified framework for DJ-based geometric measurement. Just as there is a relationship between degree and radian, similarly there is a relationship between DJ degree and DJ measure in your new trigonometric system. General relationship. General relationship. DJ angle equals 180 d DJ measure, d equals 4. DJ measure equals d 180 DJ angle, d equals 4. Expanded version. Traditional degree angles, protractors, and radian measures are primarily used to study and measure circular, cylindrical, conical, and spherical geometrical shapes. These instruments and units are effective in analyzing curved or rotational figures where measurement is based on the concept of central angles and arc lengths. Such systems of measurement are foundational in classical trigonometry and are applied extensively in the study of circular motion, wave functions, and rotational geometry. In contrast, the concept of DJ angles, DJ protractors, and DJ measures introduces a new approach for closed and polygonal figures such as squares, rectangles, triangles, cubes, cuboids, and other multi-sided geometrical forms. Unlike traditional circular-based systems, DJ measures are designed to interpret and quantify the angular and proportional relationships found within linear or closed-sided geometries. This modern approach seeks to extend trigonometric principles beyond circular dependence, offering a framework for analyzing non-circular, planar, and solid shapes in a consistent mathematical structure. DJ acute angle. A DJ acute angle is defined as any DJ angle less than 90 DJ degrees. It represents an angle smaller than a right angle within the DJ measurement system. The DJ acute angle is composed. Acute angle is composed of two fundamental parts, namely the D acute angle and the J acute angle, which together form the complete structure of the right-angled relationship in DJ trigonometry. XD acute angle. AD acute angle is defined as 45 DJ degrees or any DJ angle less than 45 DJ degrees. This type of angle represents the smaller range of acute measurements within the DJ system, focusing on sharp, narrow angular formations. The D acute angle symbolizes the lower spectrum of acute measurements and plays a significant role in the proportional and symmetrical understanding of closed geometrical figures. Figures. J acute angle. AJ acute angle is defined as 45 DJ degrees or any DJ angle greater than 45 DJ degrees but less than 90 DJ degrees. This represents the broader portion of the acute range, where the angle extends closer to the right angle while maintaining its acute nature. The J acute angle thus complements the D acute angle to complete the total range of acute measurements within the DJ system. The relationship between these two components can be expressed as right angle equals D acute angle plus J acute angle. 90 degrees degree equals 45 degrees degree plus 45 degrees degree. This relationship forms a fundamental basis for DJ trigonometry, which is primarily used in triangular geometries where one of the angles is a right angle. Through this innovative system, DJ trigonometry provides a new way to study and interpret angular relationships in closed figures such as triangles, squares, and other multi-sided geometrical structures, extending the boundaries of traditional trigonometric analysis. DJ angle less than 90 DJ degrees will be called DJ acute angle. It has two parts, D acute angle and J acute angle. 1. DJ Badwan Theorem. The DJ Badwan Theorem forms the foundational principle of DJ trigonometry, establishing a direct relationship between the sides and angles of a right-angled triangle within the DJ measurement system. Theory. In a right-angled triangle, if the D acute angle is given, the length of the side opposite to the D acute angle P can be found by multiplying the length of the side adjacent to the D acute angle O with the DJ measure X of that angle. P will always be less than or equal to O. Triangle within the DJ measurement system. Theory. In a right-angled triangle, if the D acute angle is given, the length of the side opposite to the D acute angle P can be found by multiplying the length of the side adjacent to the D acute angle O with the DJ measure X of that angle. P will always be less than or equal to O. Where equals the side opposite the given acute angle. Right pointing arrow, it can be the base or the perpendicular, depending on the position. Equals the side adjacent to the given acute angle. Right pointing arrow, it can be the base or the perpendicular, depending on the position. The result obtained from this multiplication represents the actual length of the side opposite to the D acute angle. In other words, when the adjacent side is multiplied by the DJ measure of the D acute angle, the obtained value is equal to the length of the side opposite to that angle. Of the side opposite to that angle. Let the following notations be defined. DJ measure of the D acute angle equals X. Length of the adjacent side of the D acute angle equals O. Length of the side opposite to the D acute angle equals P. Then, according to the DJ Badwan Theorem, O X equals P. X equals P O. This means that the DJ measure of AD acute angle X represents the ratio of the length of the opposite side to the adjacent side of that angle, when considered under the DJ measurement framework. O X equals P. X equals P O. This means that the DJ measure of AD acute angle X represents the ratio of the length of the opposite side to the adjacent side of that angle, when considered under the DJ measurement framework. In simple terms, the theorem explains that if the adjacent side of a right-angled triangle is known, and the DJ measure of the D acute angle is determined, then the opposite side can be directly obtained by multiplying these two values. Mathematically and conceptually, the DJ Badwan Theorem provides a new foundation for angle-side relationships in geometrical figures measured under DJ trigonometry, expanding the possibilities of non-circular angular analysis and the study of closed polygonal figures such as squares, rectangles, and triangles. By Pythagoras theorem. Hypotenuse and base in DJ measure a relation by DJ theorem. X equals P O. K2 equals A2 plus L2 dividing by square of A2 in Pythagoras theorem. O equals A, P equals L, K2 A2 equals A2 A2 plus L2 A2. K2 A2 equals 1 plus L2 A2. L2 A2 equals DJ measure 2. K equals A square root 1 plus DJ measure 2. A equals K square root 1 plus DJ measure 2. Hypotenuse and perpendicular and DJ measure a relation by DJ theorem. 1 X equals OP. K2 equals A2 plus L2. K equals A square root 1 plus DJ measure 2. A equals K square root 1 plus DJ measure 2. Hypotenuse and perpendicular and DJ measure a relation by DJ theorem. 1 X equals OP. K2 equals A2 plus L2. Dividing by the square of L2 in Pythagoras theorem. O equals A, P equals L, K2 L2 equals A2 L2 plus L2 L2. K2 per liter 2 equals A2 L2 plus 1. A2 L2 equals 1 DJ measure 2 equals L square root 1 plus 1 DJ measure 2 equals K DJ measure square root 1 plus DJ measure 2. 2 DJ theorem. 2 DJ theorem. The DJ theorem is an essential extension of DJ trigonometry, designed to generalize its principles beyond right-angled triangles. While DJ trigonometry initially defines relationships between sides and angles in right-angled geometric configurations using unique DJ angle measures, D acute and J acute, the DJ theorem ensures that these relationships can also be applied to any general triangle, regardless of whether it contains a right angle. According to this theorem, if a triangle is not right-angled, a perpendicular line can be constructed from one vertex to the opposite side or to its extension. This perpendicular divides the given triangle into two right-angled triangles, allowing each of these smaller triangles to be analyzed independently using DJ trigonometric principles. For example, consider a triangle ABC that does not contain a right angle. If a perpendicular AD is drawn from vertex A to the side BC, the triangle is divided into two right-angled triangles, OBID and ADC. These two triangles can then be examined separately. Within each right triangle, DJ trigonometric relationships, such as those defined by the DJ Badwan Theorem and the characteristic DJ angle measures, can be applied to determine the unknown sides, angles, and proportional relationships. By solving both right-angled components, the complete geometrical and angular structure of the original triangle can be established. Thus, the DJ theorem confirms two essential truths. Universality of resolution. Any triangle, whether acute, obtuse, or scalene, can be systematically resolved into two right-angled triangles by drawing a suitable perpendicular. Continuity of relationship. Continuity of relationship. The sides and angles of the original non-right-angled triangle are interconnected through DJ trigonometric principles derived from its two right-angled components. Note on DJ major and acute DJ angle. In DJ trigonometry, the concept of DJ measure plays an important role in determining the nature of the geometric relationship between angles and sides. When the DJ measure value becomes greater than a certain reference value, denoted here as 1, the system tends to behave like a square relation. This means that the triangle or geometric figure begins to follow the square perimeter relation, where the perimeter can be calculated using the constant relationship of a square, such as OR. To prevent this shift from triangular to square geometry, DJ trigonometry introduces the concept of the D acute angle. A D acute angle is defined as an angle less than 45 degrees DJ degree. Reason: why only less than 45 degrees DJ degree is used. When an angle exceeds 45 DJ degrees, the trigonometric relationship starts to align more closely with square symmetry rather than triangular relations. At 45 DJ degrees, both sides of the geometry begin to equalize, similar to a square, S diagonals, and the system starts measuring perimeter-like relations instead of pure angular relations. Therefore, in new trigonometry DJ trigonometry, the working range of the DJ acute angle is always kept below 45 DJ degrees. This ensures that the DJ system remains in the acute non-square region, maintaining the proper trigonometric relationships between sides and angles. Conclusion. Hence, if the DJ measure exceeds the 1 value, it behaves like a square perimeter function. To maintain the trigonometric nature of the system, DJ trigonometry restricts the angle to less than 45 DJ degrees, defining it as AD acute angle, which forms the foundation of the new trigonometric framework. 6. Objective. The primary objective of DJ trigonometry is to simplify and modernize traditional trigonometric concepts. Classical trigonometry, while fundamental to mathematics, is often regarded as complex and abstract, especially for learners at the foundational level. DJ trigonometry aims to overcome these challenges by introducing a simplified, logical, and proportional framework that retains mathematical accuracy while improving conceptual clarity. Simplified, logical, and proportional framework that retains mathematical accuracy while improving conceptual clarity. Unlike the traditional system that depends heavily on right-angled triangles, sine, cosine, and tangent ratios, the DJ approach offers a direct relationship between sides and angles through the concept of the DJ measure and the DJ degree. This system provides a more intuitive and accessible method for understanding geometric relationships without relying solely on trigonometric tables or calculators. One of the key applications of this new framework is in practical geometry, such as determining the height of a building, tower, or wall. Using the specially designed DJ Protractor, one can easily measure the DJ angle of elevation and then apply the proportional formulas of DJ trigonometry to compute unknown sides or dimensions. Furthermore, this theory is not limited to right-angled triangles, it extends its application to all types of triangles and closed geometric figures. By doing so, DJ trigonometry establishes a universal system of measurement and proportionality that can be applied in education, construction, architecture, and various fields of applied mathematics. In summary, the objective of DJ trigonometry is to make trigonometry simpler, more practical, and universally applicable, thereby paving the way for a new generation of mathematical understanding and problem solving. 7. Conclusion. DJ trigonometry introduces a novel and simplified framework for understanding geometric and trigonometric relationships. Unlike traditional trigonometry, which depends solely on right-angled configurations and conventional degree or radian systems, DJ trigonometry establishes a proportional and universal system that can be applied to all types of triangles and closed figures. Through the incorporation of new constants, the DJ measure, and the DJ degree concept, this theory extends trigonometric principles beyond conventional limits, making it possible to derive side and angle relationships through direct proportionality rather than complex angle functions. This system simplifies geometric analysis and enhances conceptual clarity for students, educators, and researchers alike. Moreover, the DJ framework has wide potential applications, from educational pedagogy to engineering design, architectural modeling, and geometric analysis, where rapid and proportional calculations are essential. By transforming the approach to measuring and solving non-right-angled triangles and other geometric shapes, DJ trigonometry stands as a progressive step toward redefining mathematical understanding in modern geometry. Compliance with ethical standards. Funding. This research received no funding from any organization, institution, or agency. Not applicable conflict of interest. The author declares that there is no conflict of interest associated with this research. Author's contribution. All work related to the conception, mathematical analysis, writing, and revision of the manuscript has been carried out solely by the single author. Data availability statement. All data used in this study are included within this manuscript. No external or additional datasets were generated or used. Not applicable. 8. References. 1. Overview of classical trigonometric principles describing angle-side relationships in right-angled triangles and their geometric interpretations. Traditional trigonometry describes the relationship between the sides and angles of a right-angled triangle. In contrast, DJ trigonometry extends this principle to encompass any general triangle, regardless of its angle type. By applying the DJ theorem, one can draw a perpendicular from any vertex and systematically divide the triangle into two right-angled components, thereby revealing the same relationships through proportional reasoning. A right-angled triangle. In contrast, DJ trigonometry extends this principle to encompass any general triangle, regardless of its angle type. By applying the DJ theorem, one can draw a perpendicular from any vertex and systematically divide the triangle into two right-angled components, thereby revealing the same relationships through proportional reasoning. Furthermore, the DJ Protractor, a redesigned geometric instrument based on the DJ degree system, can be effectively used for measuring and analyzing closed figures such as squares, rectangles, cubes, cuboids, and triangles, as well as other polygons with 3 or more sides. This adaptability makes DJ trigonometry not just a theoretical innovation but also a practical tool for mathematical and geometric applications.